Okay, so we're going to continue with our addition reactions. So again, a little bit shorter than the previous one, but still a bit in it. So the first one we're going to look at is simple addition reactions, and that involves a mechanism. So this here is the second mechanism that you've got to know, and then that's it. What you'll notice is this one involves ethene gas, whereas the previous mechanism involved CH4, which was methane, and don't get confused between the two of them. And then after we look at the simple addition reaction, then we're going to have a look at polymerization. So an example of a simple addition reaction we have here. So we have ethene gas, and that is just a standard C double bond C, reacting with bromine molecule, which is a BR-BR or Br2, and the BR-BR ends up splitting the double bond in the ethene, and you end up producing 1,2-dibromoethane. So both of the bromines join onto two of the carbons, and that's it. So you've gone from an alkene mixing with a bromine to two bromines on top of essentially an alkane on top of bromoethane. So what we have to do is we have to look at the mechanism. In other words, each step as to how bromine converts ethene or reacts with ethene to convert it into 1,2-dibromoethane. So let's have a look at our mechanism. So the first thing we want to look at is step one, which is polarization. One thing you've got to look at in the ethene molecule that we have here is we've got a double bond, and a double bond means that there is two pairs of electrons being shared. So this particular part there's a high concentration of negative charge. So there is a lot of negative charge inside here in this double bond. And because of that high negative charge, it causes the Br molecule to become polarized. So one side of the Br molecule becomes slightly positive and one side becomes slightly negative. That's essentially it for the first step. The second step, there's a little bit more in it. We've got heterolytic fission. And this is where the Br2 splits. And the reason why the Br2 molecule splits is because the polarization becomes so great. The polarization increases. And here's what happens. So if you can imagine, you have a bromine molecule and you have electrons being shared. You have the dot and you have the cross. When these split, what happens is the electron here moves to this bromine here. Now when something loses an electron, it becomes more positive. So this bromine here is losing an electron, therefore it ends up becoming Br positive. The other bromine, of course, gains an electron, so you end up with Br negative. And in this one, it's this bromine that has that electron, and it also has that electron. So this particular part is heterolytic fission, and ions, bromine ions, are formed. A bromine positive and a bromine negative. Once you have that, then we move on to the carbonium ion formation. Your ethene molecule. And what we're interested in is the bromine positive. So the bromine positive is attracted to this molecule because of the high negative double bond. And if you look at the molecule here, what you find is you've got an electron here and an electron here. That's in the lower part of the bond. And because the bromine is such a positive molecule, what happens is the double bond ends up splitting. And when the double bond ends up splitting, the bromine ends up joining on here, mainly because the bromine is positive and it will pop in here. Remember what this means. This means it's missing an electron. And it wants to try and get some sort of an electron back. So when it joins on here, this electron is the electron that joins on the bromine. So what happens now? Well, the double bond is gone. The bromine has joined on. This carbon on the right hand side, of course, is missing an electron. If it's missing an electron, it becomes more positive. We've got a hydrogen this way, a hydrogen this way, and we have a hydrogen that way and a hydrogen that way. We still have the 4 hydrogens. And this here is what's called the carbonium ion. Now, where do we go from here? Well, we're down to the final step. What we now have is our carbonium ion with our bromine, surrounded by hydrogens. And of course, this time we have the bromine negative, which was formed up above. And of course, it being negative is attracted to this particular carbonium ion. That then brings us to two BRs in a single bond. And the hydrogens are pushed around. So this particular substance here is your 1,2 dibromo and 2 carbons ethane. And that's the end of that mechanism. Now at the end of that mechanism then, you also have to have evidence for the mechanism, and here's the main evidence that we have is 1-bromo 2-chloroethane is formed and 2-bromoethanol is also formed, and that's something you can have a look at in your textbooks and in your notes. So moving on to polymerization reactions. So these are fairly straightforward. So what are polymers? Well, polymers are just long chain molecules, and they're made by joining together much smaller molecules. So the polymer, this is your long chain over here, and then your short chain, which is over here, is your monomer. And the monomers are basically the building blocks of this polymer. And in this particular example, we're using ethene. And ethene, when you put multiple monomers of ethene together, you get polyethene, which is shortened to obviously polythene, which is used in plastic bags. But then there are other ones. You can take a chloroethene, and when you put that together, it gets you polyvinyl chloride, which is PVC. And you can also get other ones then as well, where you can take a propene molecule and you can put multiple propene molecules together, and you will get polypropene, which is shortened to polypropene. So that's pretty much it for polymerization reactions. Again, I'm not going to go into it in huge detail because we did it in class. So that's it for that video. We're going to move on to elimination reactions next. But before we do, just a couple of ideas of where these are used. So for example, crude oil. Crude oil is used in the manufacture of polymers, in particular plastics. Right, so that's it. We're on to elimination.